This is the e-learning lesson for Wednesday, January 26th. We are going to be reviewing even and odd functions and how to use our calculators in both radians and degrees. As you can see, I have uploaded a PowerPoint on even and odd trigonometric functions. I want to remind you that we learned last semester in pre-calculus that even functions, which you can see right here, are functions that are symmetric with respect to the y-axis. Odd functions, on the other hand, are functions that are symmetric with respect to the origin. That's where you can flip the graph over one axis, then the other axis, and you still have the same graph. Or you can rotate the graph 180 degrees and you end up with the same graph. So when it comes to trigonometric functions, there are two functions that are considered even. Hold on. There are two functions that are considered even, which are the cosine and the secant functions, which means if we were to graph them, they would be symmetric with respect to the y-axis. We will do that, but not quite yet. But we're going to focus in on what happens on the unit circle here in a moment. The other remaining four trigonometric ratios, which I don't know why that does that. All right, the sine, cosecant, tangent, and cotangent functions are odd functions. Again, that means they're symmetric with respect to the origin when you graph them. We're not going to worry about the graphs yet, but we're going to see how this plays out on the unit circle. So let me go down to my unit circle below, and let's look at an ordered pair. I think I'm going to pick pi over 4. Let me change this, make this maybe I think it'll show up if I do gray. So if I do pi over 4, that's this ordered pair right here, we know that the cosine of pi over 4 is the x-coordinate. Well, if we take the cosine of negative pi over 4, so the cosine of pi over 4, we know is square root of 2 over 2. If we look at the cosine of negative pi over 4, because cosine is an even function, when we rotate clockwise negative pi over 4, that takes us to 7 pi over 4 if you were rotating counterclockwise, but clockwise, that's negative pi over 4, and this is that ordered pair. And if we look at the cosine value, it's the x-coordinate again, and it's the same. It's the square root of 2 over 2. That would be true for any position on the unit circle. For instance, pi over 6. If I look at pi over 6, we have square root of 3 over 2, comma 1/2. Well, the cosine of that angle would be square root of 3 over 2, whereas the cosine of negative pi over 6 would be at this position and this ordered pair, and the cosine value is the same because the x-coordinate in quadrant 1 and 4 is going to be positive in both quadrants. Just like in 2 and 3, the x-coordinate is going to be negative. So as a result, when you take the cosine of an angle, any angle, and then the cosine of the opposite of that angle, rotating the other direction, you are going to be symmetric with respect to the x-axis, and as a result, those ordered pairs are going to have x-coordinates that have the same sign, and therefore are the same. It would be no different if I had taken the reciprocal of cosine, the secant. The secant would be the reciprocal, and that would also be the same sign and the same outcome. The ordered pair before it's rationalized is 1 over the square root of 2, comma 1 over the square root of 2, so the secant value, reciprocal, would be square root of 2. And so would the secant of negative pi over 4. So that's what happens with even functions. The value of the cosine of negative t up here, I don't know why this is doing this. My pen. Okay, got it. So the cosine of the opposite of t is the same as the cosine of t, and the secant of the opposite of t is the same as the secant of t. Not true with odd functions. The sine, cosecant, tangent, and cotangent are odd functions, and so notice when you put in the opposite, you get the opposite of the trigonometric ratio. So let's look at that below. Same thing, but we're going to erase that and now focus on the sine, which is just one of the odd functions. So if I take the sine of pi over 4, that, of course, is the y-coordinate of square root 2 over 2. But if I take the sine of the opposite of pi over 4 in quadrant 4, of course, the y-coordinate would be negative, and therefore the opposite of the square root of 2 over 2. And that's because in quadrant 1, y-coordinates are positive, but in quadrant 4, where the opposite of the angle occurs, the y-coordinates are negative. That's also true in quadrants 2 and 3. In quadrant 2, y's are positive, but in quadrant 3, y's are negative. And that's where the opposite of the angle can be found. So the long and short of this is what's going to happen on the back side of this sheet, which I will pass out to you in class on Thursday or Friday. But take a look down here. So this is the net result. The trigonometric functions that are even are cosine and secant. Notice when you look at problems 1 and 2, the outcome is the same. The cosine of pi over 6 is square root of 3 over 2. The cosine of negative pi over 6 would also be square root of 3 over 2. And that's because they're even functions, and if you rotate clockwise or counterclockwise the same amount, the coordinate for x is going to have the same sign and same value. So numbers 11 and 12 are secant, which is also even, the reciprocal of cosine. So the secant at 4 pi over 3 is related to the cosine, and the cosine of 4 pi over 3 would be in quadrant 3, and the x-coordinate there is negative 1/2. You can see that. So the secant is the reciprocal, and that would be negative 2. But the secant of negative 4 pi over 3 would rotate clockwise and put you in quadrant 2, and it doesn't matter. The x-coordinate's negative there as well, and therefore would have to be -2. Both cosine and secant are even, so the outcomes have the same sign, same value. All of the rest of the problems here are odd functions: sine, tangent, cotangent, cosecant. Except cosine and secant, everything else is odd. So like in number 3, when you find the sine of 5 pi over 6, the value is 1/2. But if you rotate clockwise the same amount, that is going to put you from quadrant 2 in, this is quadrant 2. Well, when you rotate clockwise, that's going to be quadrant 3. And so the y value in quadrant 3 will be -1/2, but in quadrant 2 it's positive. And I can go through each of these. That's the same with tangent and cotangent and cosecant. That's because they're odd functions. And odd functions will have the opposite outcome. And that just may be another way to help you find values. I think they group them together. You are fine just using the unit circle if you want, but that's just another relationship that exists between even and odd functions. All right, what do I want to finish with? I want to finish with calculators and how we go from radians to degrees, because at the end of 4.2b, you're going to be asked to evaluate things in radians as well as degrees on your calculator. So the first thing you have to understand is you've got to be in the correct mode, which is radian mode, when you want to calculate radians. And so you need to use the mode key. I'll try to scroll that up a little. The mode key on the graphing calculator. And right here is where you can select radians or degrees. And if you want to be in radians, you select radians. If you want to be in degrees, you have to select degrees. That's the tricky part, because often people forget what mode they're in, although it does show you at the top right hand of your screen which mode you're in. So if we want to calculate radians, we need to switch to radians. And then you can see here, if I want to find the secant of pi over 12, I would first find the cosine of pi over 12, and then I would use the reciprocal, and to me, I would do it like this. I would enter cosine and then in parentheses pi divided by 12, and then I would use the x to the -1 for the reciprocal key, and that should give you the secant of pi over 12, and you should try this on your calculator. You want to see whether the secant of pi over 12 returns 1.0353. That's rounded to the nearest 4 decimal places. All right, that's it. So you want to begin 4.2b, try to finish 4.2a. You're not going to be able to do everything in 4.2b yet, but you'll be able to start it, and then with our lesson on block day, Thursday or Friday, you'll be able to finish it as well as do the practice quiz to get ready for your quizzes next week. Have a great day.